Here we go. Just open the top cover, and you can adjust the burner inside, whether you want a brighter or dimmer flame. Just use the side knob to dial it in perfectly. Then, let the light shine through these upper red lenses to project a bright red glow. Red light isn't just used for its universal warning effect. Its specific wavelength is the real key here. As light travels through the air, longer wavelengths penetrate particles more easily, and red light is around 650 nanometers. Compared to standard blue or white light, it travels significantly further and maintains excellent visibility in fog, rain, or at night. So today, we are restoring a 1940s French railway kerosene signal lamp that emits this exact red light. Our master restorer, who has already dismantled the piece, is Ocean Nava from France. Let's start the restoration. First up is this multifunctional top cover. Instead of sandblasting, he opts for a much better method today. He's using a nearly non-destructive laser cleaner to strip the rust and paint without harming the base metal. The secret lies in selective absorption. Iron oxide absorbs the laser strongly, while the metal underneath reflects it. When the high-energy beam hits, the rust instantly vaporizes, leaving the highly conductive metal core perfectly intact. However, lasers are highly directional, meaning they can't effectively reach complex nooks and crannies on the part. To solve this, he prepares a sodium carbonate solution for a secondary, non-destructive electrolytic rust removal process. Once powered, electrons flow to the negatively charged metal, gradually reducing the stubborn iron oxide into soluble ferrous ions. This safe reaction completely spares the original metal, preventing any unwanted corrosion. Even after this bath, you'll notice some stubborn black iron oxide clinging to the surface, a byproduct of the reduction. Ironically, the best way to clean this final layer is to circle back to sandblasting using white corundum abrasive. Posts and blasting, the part reveals countless small imperfections across its surface. He uses a blowtorch to remove the hood, then carefully extracts the damaged internal lens clips. To patch a prominent crack, he welds iron nails into the gap as structural fillers, planning to trim off the excess later. A basic Tiankin lid is cleverly modified to serve as a new retaining clip for the red lens, saving a lot of time. After sandblasting, the custom pieces are carefully hammered into shape and cut to fit properly. Once prepared, he uses a handheld spot welder to secure the modified cap firmly into place. Spot welding works by sending a powerful, instantaneous current through contact points, generating extreme heat to fuse the metal. After cutting away the excess material in the center, the brand new clip is officially complete. He then applies a bluing solution to create a dense, protective blue-black layer of stable iron oxide deep in the metal. Because this protective oxide layer is inherently porous, coating it with anti-rust oil offers unmatched long-term protection. Next up, he tackles to severely deformed hoods using a classic routine of hammering, reshaping, grinding, and polishing. Since there were originally 3 hoods, he now has to completely recreate the missing one from scratch. Similar to the earlier lens clip, he repurposes perfectly sized existing material to fabricate the new base. With the base ready, he uses an original hood as a template to trace and cut out a new brass sun visor. After giving it a slight bend for the proper angle, he securely binds the visor to the base using cold weld adhesive. The fuel tank base is also missing its locking latch, so he has to meticulously craft a replacement. Once the latch is formed, he mounts it with cold weld adhesive, fixing a nearby surface dent in the process. Next, he installs a brand new hinge to reliably connect the top and bottom halves. The new hood is secured with cold weld, which also doubles as a highly durable putty to effortlessly fill any surface flaws. In fact, this cold weld adhesive offers much greater structural strength than standard filler putty. For the powder coating stage, he applies a beautiful custom blended bronze top coat powder. Here is the stunning final bronze finish. What do you think of this color? Next is the badly warped carrying hook, which gets carefully hammered back into its proper, original alignment. By the way, besides being hung or hand-carried, this lamp features a square mounting slot on the side of the fuel tank. Paired with a rear bolt, it allows the lamp to be securely mounted alongside railway tracks or deep inside train cars. After a fine sanding to prep the surface, the hook also receives a sleek powder coating. The 3 original red lenses are still in fantastic shape. They simply need a thorough cleaning. If you're wondering what the concentric circles are for, it's a Fresnel lens design used specifically to focus the light. The locking latch undergoes a standard 3-step process: sandblasting, polishing, and a protective electroplating bath. Now, we can assemble the restored latch, lenses, and hook right back into their original positions. Finally, the burner gets a deep clean using acetic acid and an ultrasonic cleaner, instantly stripping away all rust and grime. After a solid round of polishing and a fresh protective coat, the burner is fully restored to prime working condition. With the burner successfully reinstalled, a beautifully replicated logo sticker is carefully applied to the housing. Tightening the mounting bolt and joining the halves with a fresh hinge pin officially completes the restoration of this 1940s French railway signal lamp. As always, rate this incredible restoration out of 10. What score would you give it? The adjuster knob controls the length of the wick, letting you easily dial in the perfect brightness for the flame. That wraps up today's restoration video. Thanks for watching, and see you next time here at Max's Restoration Realm. Goodbye.